Hi, Scarlett. I hope you're enjoying some of your time off. This is Bob Boyle, your friendly neighborhood physics teacher. And the purpose of this video is to give you an idea of what we are doing this week and to help you give you the opportunity to practice so that you can keep up and still have a decent idea of what's going on. So today or this week, we are doing calculations with significant figures and dimensional analysis. I'm going to start off with the calculations of significant figures. And there are basically two rules. First rule has to deal with when you're doing addition and subtraction. And the primary rule here is that when we are doing rounding, we have to make sure we have the correct number of significant figures, and we can determine that by rounding to the least precise measurement. Now, if you look at this particular problem, this number goes down to the thousandth. This one also goes down to the thousandth. This one goes down to the hundredth. So our answer has to be to the hundredths place. Has to end there at that second decimal. So if we did our calculation, if you punch this up in the calculator, you are going to get this value, but it has to end here. Okay. So to do that, and once again, that's because we have the 0.56 only goes to the hundredth place. Okay, so to do that, we need to round. And to round, what we're going to do is we are going to look at this digit here. Okay, since it is 5 or greater, we are going to round up. That will give us 12.91, which will be the answer to the correct number of significant figures. Okay, so the rule here is we want to round to when we're doing addition and subtraction, we want to round to the least precise number. It's a little different in multiplication and division. There, we want to round to the least number of significant figures. So I'm over here now. All right, now notice this number right here has 3 significant figures. This one has 2. Our answer has to have 2 significant figures, the least of the 2. Okay, so if we actually entered this in our calculator, this is what we're going to get. However, once again, we need to round to 2 significant figures. These would be the 2. Now to do that, we are going to look at the third figure right here. Okay, determine how we're going to round. Now, once again, since that is 5 or higher, we are going to round up, and that will give us our final answer of 6.4. Okay. Now, to help you just a little bit more, I'm going to work 2 of these problems. The first one is going to be this problem right here. Okay. Now, what you'll notice here is that this number has 2 decimal places. This only goes to 1. This goes to 3. My answer has to go to 1 decimal place. Now, before we do anything, we might want to calculate that to see what the answer is. And I have my handy dandy calculator here. And that is going to be 123.45 plus 7.1 plus 0.006. And that will give me 130.556. Okay, and once again, we need to round to the 10th decimal place, so we need to round to here. We want to look at this number because that will tell us how to round. Okay, and since this number is 5 or higher, we want to round up, and that will give us 130.6. Okay, the other one I want to do is this problem right here. Okay, now notice here I have 4 significant figures. Here I have 3, so my answer has to have 3 significant figures. Now, before I get to that point, I need to do the division, so let's do that over here. That is going to be 1. Oh, I didn't want to do that. Let's get back to where I was. That is going to be 1. Oh, do it again. One more time. Let's get back over here. I think it's because I'm on the wrong application. 125.4 divided by 3.20 And that gives me 39.1875. Okay. That's weird. 39.1875. These right here, and once again, we went around to, we went three significant digits. These are the three significant digits. This will tell me how to round. Okay, since it's 5 or higher, need to round up. That will be 39.2. Okay, so that's pretty much how you can do a multiplication problem, multiplication division problem, and an addition subtraction problem. Now, the next fun-filled things that we actually did was to talk about dimensional analysis, and the way and this basically gives us a procedure for how we can actually convert from one dimension to another. Okay, and the way this is going to work is that we are going to multiply this quantity by the number one in a different representation. For example, in a certain representation. For example, 1 inch is equal to 2.54 centimeters. So 1 can be written as the fraction 2.54 centimeters over 1 inch. And then we can actually treat the units like variables. Okay, so that's what we're going to do. Let's suppose we're starting with 25.0 inches. We want to convert that to centimeters. We know, or I will tell you, or it will be given to you, that 2.54 centimeters is equal to 1 inch. Okay, well, if that's the case, then 2.54 centimeters divided by 1 inch is equal to the unitless quantity 1. And if you multiply anything by the unitless quantity, it does not change its value. So that's what we're doing here. We're multiplying by 1. And the best part is also that we can treat these units like variables. Okay, so since I have inches in the numerator and inches in the denominator, they will cancel out, just like we have here. And the only thing we have left is centimeters. Okay, and that's what we're doing here. Okay, so we multiplied it by 1. We multiplied 25 inches by 1. We're going to get centimeters, and we just can go ahead and do the math. And if we do, we're going to have 25.0 times 2.54, and that will give us 63.5. The inches cancel, and the only thing we have left are centimeters. Okay, let me show you that with one of the problems that we actually have on our paper. That would be problem 2, this one right here. Here, I want to convert 3.5 hours to minutes. And I know that 1 hour is equal to 60 minutes. Okay, and if that's the case, then 60 minutes divided by 1 hour is equal to 1, and that will be my conversion factor. Okay, so we can start off with 3.50. And of course, you want to write our conversion factor so that the unit that we want to cancel is going to be on the denominator, which is what we have here. So I want to multiply that by 60 minutes divided by 1 hour. Okay, the hours will cancel. The only thing I have left will be minutes. Okay, and it turns out that, try to get to the right apple over here. There we go. 60 times 3.5 is equals to 210. Okay, notice here we have three significant figures. This is actually a conversion, so it has an infinite number of sig figs. You don't need to worry about that. And then and that should be minutes, sorry. And therefore our answer is going to be 210 minutes. All right, and then the last thing that we actually did for this week, or that we're going to do, actually I think it's going to be Friday for your class, is basically dimensional analysis, but basically a multi-step approach, which is just like this step here, The only difference is we'll have to take multiple steps to actually get to the units that we want. Okay? Now, in this particular case, we are going to start off with 60 miles an hour. I want to convert that to meters per second. What do I know? Well, I know that 1 mile is equal to 1,609 meters, and I know that 1 hour is equal to 3,600 seconds. Okay, so, and I want miles to cancel, and I want to end up with meters per second. Notice how I have miles in the numerator. That means I want miles in the denominator. I want 1 mile in the denominator, 1609 meters in the numerator. Okay, if I do, then these will cancel. Notice here I have hours in the denominator. I want hours over here in the numerator. Then they will cancel. And of course, then I also need to include 3,600 so that I'm actually multiplying by 1. So when I do all that, I had the units that I want meters per second, just kind of like what you have here. Now, when you knock that out in your calculator, that is going to be 60. Did it again. Hang on. Let me bring this back up. Bring this back up to where it belongs. Okay, 60 times 1609 divided by 3600. That's supposed to be divided by, not minus. 3600. And that gives me 26.81 seconds. Now, since my 60 has 3 significant figures, and technically these conversions have an infinite number of significant figures, in other words, my position is going to be driven by this, I want to go to 3. That would be 26.81. Okay, now to round, I of course want to look at that. Okay, since that's less than 5, I don't round up, and that gives me 26.8. Okay, so now what I want to do is just one problem from here to give you an idea how this works with something different. And let's take a look at 2. Okay, now here, a runner covers 10 kilometers in 48 minutes. And we want to express their speed in miles per hour. Okay, now speed is defined as distance traveled divided by time. In this case, the distance traveled is 10.0 kilometers divided by 48 minutes, 48.0 minutes, sorry about that. And remember, we want meters per second. Now we have here that 1 kilometer is equal, no, I'm sorry, we want miles per hour. Sorry, miles per hour. That's what we want. I kind of missed that part right there. Okay, so one conversion we have is that 1 kilometer is equal to 1,000 meters. So I can go ahead and do that. Okay, since I have kilometer up here, I want kilometer in the denominator, so that's 1 kilometer, 1,000 meters. Okay, the next conversion is 1 mile is equal to 1,609 meters. Okay, once again, I'm going for miles. I have meters up here, so I want to get rid of meters. This is one of these 2 stages. So 1,609 meters is, no, I forgot the 9 there. Sorry about that. 9 meters is equal to 1 mile. So that's multiplying by 1 there. Now I need to give myself a little bit of room here. So let's erase all this stuff right here. Actually, let me go ahead and clean this up. Okay, and then finally, I notice here I have minutes in the denominator. So to get rid of the minutes, that should be minutes, by the way. I want minutes in the numerator, 60 minutes over 1 hour. Okay, and take a look what happens. The minutes cancel. The kilometers cancel. This should be meters. The meters cancel. And what do I have left? I have miles right there, miles per hour. Okay, the units I'm looking for. How would I compute that? It looks daunting, but it really isn't. I can just do 10. Well, first I can get to the right location. There we go. 10 divided by 48, okay, times 1,000 divided by 1609 times 60. So since we're doing straight multiplication, it actually is straightforward, except that should be 60, not 600. Let me get rid of that. And that gives me 0.7768 miles an hour. 0.7768 miles per hour. Now notice here, I have three sig figs here. I have three sig figs here. My answer has to have three sig figs. So this right here will be my 3. This is the thing I need to round against. And since that is greater than 5, I'm going to round up. So this will round to 0.777 miles per hour. Okay, so hopefully that will get you started. And I apologize if this took a little bit too long, but hopefully this will get you started. And if you get into a jam, maybe your parents can help, and or otherwise, I'll be more than happy to work with you on this when you come back. And also, before you come back, I actually might provide you an answer key so you can actually kind of follow the problems and get an idea of how they work. So that's all I have. I hope you enjoy the rest of your week, and I will see you on Monday. And this is Bob Boyle signing off.